Now, I want to talk about what happens when a wave changes mediums, when it hits a boundary between one medium and another. First, the medium is the material through which the wave is traveling. In space, the medium is the vacuum. Electromagnetic waves can travel through a vacuum. They can also travel through air. In that case, the air is the medium. Sound travels through air. That's the medium. Sound can travel through a steel rod. That's the putting your head on a train track to hear the train coming from a far distance away. Please make sure you get off the track before the train gets too close. So the medium is the material, the physical material that the object, that the wave is traveling through. So when the wave hits a boundary from one medium to another, three basic things can happen. First off, reflection. Reflection means that I got my boundary right here, I got my wave coming in, the wave hits the boundary and it bounces back. That is reflection. The other one is refraction. When a wave hits another medium, some of it will actually go through. Some of it gets transferred into it. And you basically get oscillations in the new medium. Now what happens when that what happens to the wave is that generally the frequency will change. So if you have, or the period or the wavelength, they're all tied together. So the classic example is if I have a glass of water and I put a pencil in it and the pencil looks bent. That's because when the light is bouncing off the pencil and is coming up towards my eye, as it comes up from the water medium into the air, it bends. And so that's what's happening there. Same thing happens with sound. There's a video out there that Hewitt does of refraction of sound as it basically, it's bending going from a higher density air to lower density air. You get the same type principle with mirages also. And the third, so that's refraction. Reflection is the bounce. Refraction is the bending of light when it changes mediums. And the other one is diffraction, where a wave will interfere with itself because of the bending property. As it goes around corners, it bends. And I did that in another video. It's basically, this is when you look through the crack between two fingers right here and you see the banding, the black little lines there, this is called single slit diffraction. But that's really best talked about at a different location in the course. So mainly I want to talk about the reflection piece of it. So reflection, as a wave hits a boundary and it reflects, there are two basic things that are types of reflection that will happen. One of them is the reflection of, I got a wave coming in like this, it hits the boundary, and basically it bounces back like this. The other one, as the wave hits the boundary, it flips over and moves away like this. So which one is going to happen depends upon what type of boundary it is. And so now let's think about what happens now I'm going to stick this in the next video. So basically, when it hits a boundary, when dealing with a reflection, it's either going to basically bounce straight back or it's going to invert.